Good morning, class 4. Today we're going to do a science lesson on the brain. And I've borrowed Joel here to hold a ruler for me. Now, this is one experiment that you're going to be able to do today. And I want to show you about the way your brain sends and receives signals. Now, I'm going to drop this ruler with my right hand and catch it with my left hand. Okay? When I did that, it took 2.5 inches, okay, before I could catch it. I'm going to do it one more time. I'm going to hold it at the bottom and then, oh, that was only 1.5 inches, okay? Now, I'm going to have Joel do the same thing. He's going to hold the ruler at the top, and I'm going to hold the bottom. And by lining up the numbers so I can see how many inches it takes before I can catch the ruler. Or not catch the ruler. Let's try that again. This is not the first time I've missed it. Or the second time. We're going to do this one more time, and this time I'm going to catch the ruler. All right, that was 10.5 inches. Thank you, Joel. You can go back and do your homework. All right, let me move this computer over here to where I normally teach my lessons from. Now, the reasoning behind that is when I had the ruler and I dropped the ruler, I already knew that I was going to let it go. And so I already had sent the signal to catch it with my other hand before I'd even released it. But when Joel was dropping the ruler, all I had was the incoming signal of the visual of the ruler moving, rather than everything else. So it took longer for my ability to catch the ruler. So today, one of the things I want you to do is I want you to try this. I want you to take a ruler, and I want you to try catching it yourself, and then have someone else do the same thing. And you can even maybe check out, see whether your siblings or parents who has the faster reflexes. Mrs. Seidel clearly does not have very great reflexes because I completely dropped the ruler. Now, we're looking at the brain and the nervous system and what that looks like together. So once again, we have our good buddy Harvey. And Harvey has a brain up here. Okay, and I can take out Harvey's brain. And you can see what it looks like on the side. You can see up here the inside of his head where the brain goes. Now, I had a complete brain model, but believe it or not, someone lost my brain. I lost my mind. Literally lost my mind. So I only have 3/4 of the brain left, so I'm only going to show you half of the brain. Now, this is what we call a cross-section of the brain. And we looked at these pictures the other day in the book, and so this is not much different. And then you can open it up this way as well and see some of the different things that are part of the brain. Now, this brain it has all of those compartments that we talked about, all those pieces that we talked about with the learning and the understanding. You have your brain head. Hopefully you've got your brain. Oops, I'm going to turn it sideways. And just like the backwards bike, I keep doing everything in reverse because I'm looking at myself doing it. Okay, so you've got your brain hat. And on your brain hat, it tells you what things are being done in each area. You can see on this side, it's got art and music. But on this side of the same frontal lobe, you've got math problems and things like that. And you have the motor cortex. You have the sensory cortex, what is it called? Sorry, the parietal lobe, the occipital lobe, the temporal lobes. Okay, you can see that there's speech on this side, but there's smell on this side. So there's smell on both sides. There's hearing on both sides and smell, but only it looks like speech on the one side. And so your left and right brains do different things, and we'll talk a little bit more about that in a minute as well. You're going to read today, and it's in your instructions, that you're going to read the brain and the nerves section of your Christian Liberty Reader, pages 30 to 33 in that book. Okay, you're going to be reading that. And then you're going to be doing some of the activities that we were going to talk about in our lesson. Now, the brain is that main part, but beyond that is the nerve, is the spinal cord that sends the nerves down. And so you can see Harvey here. Harvey has all these vertebrae, these bones that are here coming down, and inside them there is this nerve. Actually, I don't think this comes out, but maybe it does. Maybe I can take this part of Harvey. Oh, I can take this out. Okay, so here is the vertebrae on Harvey, and the central nervous system has this spinal cord with the nerves that run through it. Now, I do not have a real human person to be able to do that with. But I do have some of these deer bones that were on our nature table. And I put them together using string and a straw and some fun tack to kind of give you an idea of what it is. These bones that are in your... Oops, I'm taking the spring apart. These bones that are in your backbone, vertebrae, have a hole in them. You can see that. Now, this is a deer bone, but you also have this in your back. The nerves that run from your brain through the body are like this yarn, and I have this spinal cord here. I've got this larger one, this thicker plastic one that's going through, and then you can see that between the vertebrae, these nerves pop out between the vertebrae, and then the fun tack here is the cushioning. There's actually cushioning that helps it. Now, Mrs. Seidel hurt her back really bad about 5 years ago. Yeah, about 5 years ago. And what happened was that cushioning that comes between those, what would happen is when I lean forward, the cushioning gets moved. It kind of pushes out, it squeezes it out. So I'm going to take the fun tack and kind of give it to you. So when I would bend forward, I would be squishing down on this side, but this side would push out. And then I would stand back up again. Then I would squish down. Well, I was carrying boxes. My mom had passed away, and we were cleaning out our house, and there were books and books and books and huge, heavy boxes. And I kept leaning down and picking them up and leaning down and picking them up. And I kept squishing this part, and this kept pushing out and pushing out. And these are called the discs that separate your back. And I herniated my disc. I actually pushed it out too far. And it caused the nerve, because the nerves are between it, it caused all this pinching in the nerves. And I'll tell you what it felt like. It felt like electrical shocks going through my whole body. When I finally was able to come back to school after a couple days, I ended up in the hospital for a little while. After I came back to school, I remember telling everyone, don't touch me. Like, put a force field around Mrs. Seidel so that no one would touch me, because it was so painful having that out, because I damaged something that was touching the nerve. So even though it wasn't my arm that was hurting, right? The nerves were through my back. Those nerves go to my arms, they go to my legs, they go all over the place. And so I was hurting it. So maybe you've been to a chiropractor. I once had this really unusual pain in my side, and the chiropractor adjusted my neck, and I was like, oh, the pain in my side went away that I didn't even know was connected, because those nerves are running through your body. And so we want to be very careful. You probably have heard people talk about things like epidurals or spinal taps or things like that, where they're actually putting needles in. There's fluid that's in that spinal cord as well. And so there's medical ways that they can numb your body putting stuff into your spinal cord. Now, maybe not spinal cord, spinal fluid. I'm not really 100% sure. I am not a doctor. But I know that they do certain things like that. They can also do tests by taking fluid out of your spinal cord. There are certain tests that need to be done in order to actually test the fluid. And so these are important things to learn about. Now, picture yourself, this is from a different book, picture yourself walking around a corner, counting cracks in the sidewalk. Someone shouts. You look up to find you are about to be run down by a crazy person on a fast skateboard. Your eyes widen, your muscles tighten, you gasp, your heart jumps. In a split second, your brain has sized up your plight. Suddenly, your muscles send you flying into a bush, safe, all before you knew it was happening. These lightning-fast reflexes were the work of your nervous system, the body's mission control. In less than a second, about 100,000 nerve cells relay all sorts of signals to move you out of harm's way. When your nervous system isn't responding in emergencies, it coordinates the normal work of your trillions of cells. It keeps tabs on the internal operations as well as what goes on in the world outside your skin. So it's got a million things it has to do, but then there are other things like emergency situations. I never have to worry about my heart beating or my lungs breathing. They do that on their own. There are certain things that I do need my brain to tell my body to do, and I have to look at this information, get all the data from around me, and then my brain acts. Your nervous system is irritable. Now, this is not like mysuicidal when I wake up in the morning and I'm irritable because I'm not a morning person. This is just that your nervous system responds to the basic information coming around you. It responds to that. Even plants do that, even though they don't have a nervous system, right? If you have a plant at the window and you have its leaves facing the sunlight, and then you turn the plant so that they're away from it, they'll turn back, right? They'll move in relation to it. Even like a plant will do that. But your body is more advanced. And we talked about all of that with our first trimester study when we looked at microscopic creatures and how they responded to the environment, as well as plants responding. Ours is a much more advanced system in how it responds. Now, you probably have had some unusual things maybe happen in your nervous system that maybe you're not even thinking about. But maybe you've hit your funny bone, right? You hit it and you got these weird, tingling, sharp... Oh, no. Harvey's guts all fell out. He just lost all of his intestines. They just popped right out. You've hit your funny bone and you get all those tingling, weird things, and it kind of almost hurts or whatever because you've hit it. That's part of your nervous system. It's doing what it's supposed to do, but you've got a nerve there that's being reacted to. Now, we are going to do a couple of experiments. You've probably been to the doctor's office and he's hit your knee or she's hit your knee with the little hammer thing, and you get your knee goes out and it you can't see it because my knee is not that high, but you hit it and the knee like jerks without you trying to do anything. Well, there's other things that do that. Now, I'm going to take the computer again, and I'm going to take it to a doorway, and I'm going to show you what happens. I need a skinny doorway. Mysuicidal is not that large. I'm going to show you my closet with my heater in it. This is my closet. I'm going to turn you sideways so you can see mysuicidal do a crazy experiment. Nope, you can't see mysuicidal do a crazy experiment. How about that? Can you see now? Okay, mysuicidal is going to go into the closet door, and I'm going to push my arms against the door frame. You can't really see this well, but I'm in the door frame, and I'm pushing my arms like this. Actually, this might even work really, really hard against it for 30 seconds, and then see what happens. So you're going to go into the doorway. You're going to put your arms in the doorway and push as hard as you can outside, pushing against it with both arms. And then when you take your arms away after doing that, you're going to see what happens to your arms and how they feel after. But you have to keep pushing. And you can't see this, but I'm pushing as hard as I can on these two railing pieces in my house to get them to work. Okay? Now, I think that's got to be pretty close to 30 seconds. I'm going to take them out. Yeah, it didn't work. You're going to try it, okay? And moving the computer. And you're going to put your arms in the doorway, push as hard as you can. You saw my hole in my ceiling. I'm just taking a tour of my house today, huh? As hard as you can. So you push your arms out on the door frame, harder, and for 30 seconds. And then when you come out, you're going to realize that your arms are acting in a way that is not the way they would normally act. Okay. Another thing you're going to do is you're going to take a dollar bill and you're going to drop it and try to catch it with your same hand. It has to be held, and I'll show you. I'm actually going to upload the pictures of the projects that I want you to do so that you can see them, so that you know what you're doing. Okay? And see if you can catch that. Try it with one hand. It's giving you options. Now, other things that you can do to learn about how your brain thinks and what happens is we talk a lot about intelligence. Now, I mentioned in the last video that mysuicidal majored in psychology, and psychology talks about how your brain is functioning and what it's doing and how it's learning. And a lot of the things that we learn are habit-based, and you get into habits and then you repeat them. So because I'm not a morning person, I say this all the time, I have all these habits that I put in place, orders and routines to help me function normally in the morning when my brain is not maybe as active and functioning as it should be. And so one day I got a cup of tea and I got in the car and I went to work, and on my way to work I realized I didn't put a tea bag in my tea. It was just water. And I say one day, it happened more than one time. But I got out of my routine, and I'm used to doing certain things a certain way, and I just went on and missed that step in the routine. Sometimes you forget things when you get out of your routine because you're used to doing it in a certain manner, and something stops that and you get out of sync. We have these habits, and when we continue to do those habits over and over again, we don't have to think so hard. When I was in my psychology class, we had to pick one behavior that we wanted to change about ourselves. And we had to have a whole process, a learning process, in order to come up with a way to change a behavior, a negative behavior that we wanted to get rid of, or introduce a positive behavior into our life. So maybe people do this when maybe they're dieting. They try to change the way they're eating, their eating habits. Or maybe they want to start an exercise program and they're changing the way that they behave. Maybe you're trying to change the way you do your study habits because now you're home. And so every day you're trying to get that into a routine, but you haven't been doing it long enough for those routines to be an automatic process. You have to still think every day, what am I doing? How does this work? What's going on? And even for Mrs. Seidel, a lot of times I forget what day of the week it is because today is Wednesday. But for you, it's Friday. I'm doing Friday's videos on Wednesday, and so I get off track because I'm thinking about Friday, but it's actually Wednesday for me. When you get this, it'll be Friday for you. And so oftentimes my days are confused because this is not my normal routine. Eventually, if I do this for a long enough time, I'll always know when I'm talking about Friday, it's Wednesday, and I'll get into those habits. But we're not there yet. And so you're trying to get the part of your brain, the thinking part of your brain, to recreate habits and routines that make it easier. They actually create memories inside your brain. So try writing your name out and see how long it takes. Maybe you've got a stopwatch. Maybe you want to write it 10 times to see how long it takes to do it for something a little bit easier than just your one name. But write your first and last name. Maybe try it 10 times. Then time it again, writing it backwards. How long does it take you to do it backwards? How about writing something, a sentence, and there's some example sentences that are in this book, writing those sentences that without stopping to cross your T or dot your I or a J or anything else that needs to be dotted. We're used to often doing those things at the end of your word. Sometimes you do it right when you're doing it, like you get to the letter, you dot it in print. But in cursive, you often, at the end of the word, you go back and dot and cross, dot and cross. If you went through the whole sentence without dotting and crossing, it's outside of your normal, and it's harder to do. So try doing that and seeing how hard it is for you to do that task. Now, let's talk about memory, because memory, again, is part of what's in your head. So is sleeping, the process of sleeping and dreams, all of that. That was one of my favorite things to study when I was in school, was dreams and sleeping. Have you ever wondered what it would be like if you woke up each day with a blank memory? You'd have to search your house to find the bathroom. Every morning you'd have to meet your mom and dad all over again. Of course, you could read your favorite stories over and over if you could remember how to read. Memory is important. It allows you to form habits so that you can think about something else while you tie your shoes. It lets you retain muscle skills. If you fell off of a boat today, you wouldn't drown because you learned how to swim last summer. Once you solve a problem, it's a lot faster the next time. Remembering the answer can help you when it comes up against a different but similar problem. No one is certain how the brain remembers. It's thought that information is stored in the cerebral cortex by changes in the brain's chemicals. Okay? And so, cerebral cortex, I don't see that on here. Where is the cerebral cortex? This is the frontal lobe. So I'm not sure the answer on where our brain is. That is. Okay. Short-term memories only last seconds. These are fleeting sense impressions, like glancing up and noticing clouds in the skies. Medium memory is remembering a phone number long enough to dial it or cramming for an exam. These memories may last moments or a few hours. Maybe you've taken one of those tests where someone had all these random objects on a tray covered up, and they took it off and they said, okay, look at this for like a minute, and then they covered it up and said, what do you remember? We do that with picture study, right? We do that with narration to some extent too, where you're trying to remember for a few minutes what you just heard or just saw, and then that memory's gone. You don't remember. That's why Mrs. Seidel is still reading the Johnny Tremain books and The Horse and His Boy. I'm going to read these every single year because I don't have all of that information stored in my long-term memory. I'll remember it for the short term. I'll read that book and I'll have those memories, and I'll take notes when I'm writing my lesson plans, but I won't remember everything about it. I'll remember the big pictures. Those are in my long-term memory. Long-term memories are the kinds that are sorted, sifted, and fixed in your mind. These might include multiplication tables or pictures of what your mom looks like or your most embarrassing moment. Now, the goal of narration, when we have you tell it back write it down, is to move things into a longer term memory, to store them so that you have them for longer. You now just listened to it. Your neighbor told it back. You talked about it. Now it's more than a few minutes. Now you've got the memory a little bit more deeply rooted in your head. And the goal is to move something from that middle term memory back into the short term memory. Maybe you've had a situation where you were going somewhere. I know as a driver, sometimes this happens to me. I'm driving somewhere and I get there and I go, I don't remember getting here. Like, I don't remember the drive here. I got thinking about something else, and then my brain didn't store the short-term memories. I know if the light turned red, I stopped. My brain was doing all those things, but my brain started thinking about something else, and I stopped recording, moving those short-term memories into a longer term memory while I was in the process. And so you probably had those experiences where you got sidetracked thinking about something else and your brain just didn't move the short term memories in. It was still doing all it needed to do. You still walked, your legs still worked, you didn't trip when you were walking, but your brain didn't keep those memories in. Your brain is going to forget a whole lot more than it's going to remember. And forgetting is important. You need to forget certain things. You can't keep everything in. People who have photographic memories, who can look at a book and go through the pages and remember everything, a lot of times they don't like that. They want to be able to forget more because it's so much information to keep storing. And so your brain just doesn't bother storing it. Now, sometimes there's a brain injury. Maybe you've heard about concussions, right? You hit your head. And this can damage the memory process. Now, we had an incident where Joel actually got a concussion. I'm pointing to where his bedroom is because it's down that way. Joel got a concussion, and he had what they call persistence, was one of the symptoms of his concussion. He reset his mind about every 3 minutes. If he came in, he broke it, he busted up his lip when he fell down, and he obviously had this concussion that came with it. And he came in, they were playing a game outside, he got hit and fell down, and that's when he got the concussion. And he came back in and he was crying. He was young, and he was young enough, he was probably about 7. He was young enough that we weren't really sure what was going on with him. He kept repeating things, and he would forget. He's like, why is my lip hurt? And we're like, well, you busted it open when you fell down. I fell down? We're like, yeah, you hit your head. That's why I have a headache. And then it would go on. And we had company at the time, and one of the people that was over tried to distract him from this. We didn't realize right off the bat that this was what a concussion was. We'd never seen it before. And he gave Joel a coin, Chuck E. Cheese coin, to play with. And Joel was like, where'd this come from? And we're like, Peter gave it to you. And he's like, thank you. And then, and we kept having to repeat it over and over. So finally we took him to the emergency room. And this went on for hours until he went to bed at night. We were up till after midnight probably with the emergency room. He just, every 3 minutes, where are we? Why are we in the car? We're going to the hospital. Why are we going to the hospital? You hit your head. I did? Maybe that's why I have a headache. Over and over and over again. When we woke up in the morning, he had no memory of anything that happened the night before. Nothing. He was back to being normal. He didn't know what happened. He asked, why am I in the wrong bedroom? Because we kept him downstairs closer to us. Why am I down here? Why do I have a headache? And once we told him, he retained all of the memories after he woke up in the morning, but absolutely nothing. He has no memory of what happened before. That can happen when we have an injury in our brain. Now, there's a lot of interesting things that you can learn about your brain. It goes on and on and on. It's one of my favorite things. It's why I majored in psychology. But there's one more thing that we're going to talk about, and that's the left and right dominance. So we talked about this before, the idea of your left and right brain. Okay, so this is my right hand. My right hand is connected with the nervous system to my left brain. And my left hand is connected to my right brain. Now this should be backwards, I'm assuming, for you because I'm facing you. So if I turn around this way, this is my right hand and my left brain. Okay? So when we talk about the things that are inside your brain, and we looked at that part of the cortex, if this is my right side is connected to my left brain, you can see on this there are things like creativity and art, sculpture, music. All of those things are in this left side. They often are connected to these are on the right side. They're connected to my left hand. On this side, we have things like math and logic, sequencing, all of that are in the left side connected to my right hand. Now, this is not a perfect example, but a lot of times people will say that people who are left-handed tend to be more creative because they're using the right creative side of their brain more often, and the right-handed people are using the left side of your brain more. Now, there's so much research that talks about these things, but remember that between the left and right side, you don't have it, I have tape. There are connections all the way through your brain that connect the left and the right side of the brain. And there's a lot of research on those connections. You actually don't need them to survive. So it seems that females have more connections, stronger connections between their left and the right side than males do. It's just one of the biological differences. And they know that you can cut them completely. So people who have epileptic seizures, if you've ever heard someone with epilepsy, sometimes in extreme cases, they have to cut the connections in order to stop the misfiring that causes the seizures to happen. So in people who have had that happen, they get information from the right and left eye as well. So the right eye is sending to the left brain and the left eye to the right brain. And what happens is they'll show them a picture of like a piece of apple pie. And they'll say, what is this? But they'll cover one eye. And the one eye, they'll be like, oh, it's warm and sweet and tasty. And they're like, what's it called? I have no idea. Then they'll cover the other eye and they'll be like, what is it? They're like, it's pie. And they're like, what's pie? I have no idea. The verbal and the understanding are in different parts. But because your brains are connected, your brain takes all these things. After my mother-in-law had a stroke, she had a really hard time coming up with the words for certain things. What's that thing that I write on and I pay my bills with? A checkbook. Yes, I need that. Like, she couldn't remember those words. And so because we store pieces of our memories and our knowledge in different places in our brain, we often need those connections to get to those places. It's really incredibly fascinating. It's one of my favorite things to learn about. Now, if you are right-handed, it does not mean you're not artistic, and if you're left-handed, it doesn't mean you must be artistic, or that you won't be as good at math if you're left-handed, because that's completely not true at all, and we know that. But there are definitely differences in the way right and left-handed people do. However, you are dominant in a hand, you're dominant in a foot, you're dominant in an eye. There's all sorts of dominances that happen, and so one of the ways that we determine dominance is if you're writing, which hand do you write with? Now, there are people who are what we call ambidextrous. They use both their left and their right hand equally well. Everybody can use both hands, assuming that they're normally functioning hands. We did that experiment where we had to write with our non-dominant hand when we talked about the Civil War and how people had injuries and they had to start using a non-dominant hand to write with because they lost the use of their dominant hand. But it's not usually equally well. And so I might be able to write with my right hand, but it doesn't mean I'm going to be able to write with my left hand, but it doesn't mean I'm going to be able to write as easily with it. Now, Mrs. Seidel has 3 biological children who are all left-handed. And each one was more dominant with their left-handed traits than the one before them. So Caleb, my oldest, is the least left dominant of all my kids. And Joel is the most left dominant. But Abigail, who fell somewhere in between them in her dominance, is the only one that needed to use a left-handed guitar. The other 2 boys learned to play the guitar using their right hand when they learned it, it's easier because guitars are typically right-handed. The same thing with feet. When you are playing the piano, you need to use both hands. When you're playing soccer, you need to use both feet. You need to learn how to use both feet, but you will tend to be dominant with one foot. So I can tell my hand dominance by which hand I choose to write with when I write. There are people who write with one hand and draw with another hand because of the different parts of your brain, but that's really unusual. Same thing with feet. You pick one foot to be more dominant. You'll notice that more if you skateboard or snowboard, where you have to have one foot in front. Which foot do I put in? Do I go down the mountain like this, or with a skateboard like this, or do I put this foot forward and go down this way? And so there's a dominance there. Which eye is dominant? So if I want to turn my dominance, I'm going to look at an object. So I'm picking a lantern I have across the way. I'm going to put my thumb completely in front of it. And then I'm going to close one eye. And then I'm going to close the other eye. when I have both eyes open and I cover it with my thumb, it's a little bit blurry because I'm trying to get to look at one item, and so it's not completely blurry, but I'm not completely clear because of that. But I'm still going to cover the majority of the lantern with my thumb, so I can't see the majority of the lantern. When I close my left eye and my right eye is there, it didn't move much. But if I close my right eye, I'm way off. My thumb is not even close to it, which means my right eye, when the eye that was open when it was still covered, is the one that I favor. I favor that eye. And so I am right eye dominant. I am right hand dominant. I am right eye dominant, and I am right leg dominant. You can be mixed dominance, and sometimes they say that if your eye and your hand dominance doesn't match, it can be there can be more learning issues with people who are doing that. So try to figure out your dominance today. Now, and this is a longer lesson because you had shorter things for other stuff, so I went going to make science a little longer today because you just had a vocab test and a math test, which is maybe not as exciting for you. And so this lesson is a little bit longer, but here are some facts to go along with our lesson today. The brain is more complicated than the best computer. It operates on the amount of electric power that would light a 10-watt bulb. So you have electrical impulses. We talked about them before. To light a 10-watt light bulb. If the brain were lifted out of the skull and spread out, it would cover a page of newspaper about 2 feet square. So if you laid it all out. And your brain is more watery than your blood. It is 85% water. It is also an oxygen eater. It weighs about 3 pounds or 1/50th, 1/50 of your total adult weight. But it uses 25% of the oxygen that you breathe in. So those are your fun facts. You're going to try out your experiments, and you're going to tell me about how they went. All right, have a great day.